Well, I hope you all survived the first talk. The second talk is going to look a little bit at geological history. So, as members now of this Academy of the Lynxes, what could we learn from looking at history? Because even if we don't understand it, nature tells us a lot. The sun comes up every day. People years ago thought the earth was flat, but they still knew, and they could still predict that the sun would be there every day. So there are a lot of things we could predict from patterns, but we may not be able to explain them. And if we put on different glasses, we see different things. And if a climate optometrist gave us climate glasses, it's amazing how we might interpret our climate history. So we could look at back 150 years, 1,000 years, 3,000 years, 15 million years. And every time we look, we're getting a little bit more wise about how complex climate is, but also the idea that our present climate change is unprecedented, that idea starts to go out the window. If we look back 150 years, we've been warming. There's no denying climate change. We've been warming. We're not denying, by the way, in the last talk, that CO2 hasn't had some influence. What we're saying, it's not the boss. Water vapour's the boss in the sun, but it's there. Glaciers have been retreating. You'll get an odd glacier somewhere because there's a quirk of snowfall that makes sense, but on the whole, glaciers retreating. Antarctica, by the way, is in balance. The latest research from NASA in New York, from Dr Swaley, increased snowfall because of slight warming has balanced ice loss in West Antarctica. Greenland, though, is losing a bit. So let's have a curtain looking at history, and there's our warming spike, the last 150 years. But if we went back 400 years, we're in a cold period called the Little Ice Age. Glaciers are advancing in Patagonia, in Europe. Christians are having processions to the bases of glacier in Switzerland and in France, begging God to stop the glaciers coming down and wrecking their villages. It's well documented, these Christian processions in this period. And also, you've also probably heard about the festivals on the Thames during that period that have iced over. They had parties. There was a war between Denmark and Sweden. The Baltic was frozen over, so the King of Sweden found he just galloped across the Baltic. No problem. Couldn't do that today. And what was interesting about this period now, we know, there was no sunspots for about 60 years. And we also know, between 1795 and 1810, there was no sunspots. Or very few. So somehow there's some relationship between lack of sunspots on the sun and a cold period. Whether we can explain it or not, it's immaterial. It's like it happens. You might notice, we'll talk about it later, that sunspot numbers have been dropping. That's why the Russians are predicting a cold period within the next 30 years. But anyhow, there's that dip, the Little Ice Age. If we go back 800 years, we're in this medieval warm period. Cathedrals are being built. There's a population boom in the Northern Hemisphere particularly. Maize in Minnesota. The Vikings had cattle in Greenland. There was a couple of bishops in Greenland communicating with the Pope. I've been privileged to go to Iceland. I didn't quite get to Greenland, but they were burying their dead. You couldn't bury the dead there now because of the permafrost. Crowbar would only go in a few inches. They were burying their dead. So obviously there would have been less Antarctic pack ice in that time. In England, the vineyards were in southern England. In the southern hemisphere, some people said, oh, the medieval warm period is only a northern event. The spike recently is due to CO2 and greenhouse gases, and the medieval warm period is just a local event in the northern hemisphere. Well, the medieval warm period evidence is from 50 north to 70 north mainly. England, southern England is about 50 north. If you go to 50 south, where are you? Well, Cape Town's about 35 south. You're out in the Southern Ocean. So if you start looking in South Africa or in Australia for this medieval warm period, you're looking at the wrong equivalent latitudes. It's as you get away from the tropics that the climate is more sensitive to change. Just for fun, I put England in the Southern Hemisphere. Did you know that's how far down it is? And what was really funny, when I got out the book, that's right. I had some guy write it down. How dare you put England upside down? I said I was just trying to make a point. But anyhow, Dr. Ian Rosenthal at Lamont Doherty Observatory in New York, where I was privileged to be a guest at one stage for a month, they've analysed a lot of fossils on the ocean floor. Now, when the pack ice freezes in Antarctica, that ice is less salty. So the water under it is saltier and drops to the ocean floor, then it migrates. So even up to 10 degrees north, all the water on the bottom of the ocean floor is from the Antarctic. So the fossils that are living on that ocean floor, they are living in a temperature that is related to the temperature in that southern ocean near Antarctica. When Dr. Rosenthal analysed thousands of fossils, he found there was a medieval warm period at the same date as in the Northern Hemisphere, and the Roman period, and we'll look back a bit further. There's no doubt that the medieval warm period was a world event. And the Chinese have done, well, in northwest China, they've done a lot of research there with the Chinese. The Germans, in their characteristic thoroughness, got out this diagram, and it's in a German periodical. This shows peer-reviewed articles showing warmth in the medieval period. You can see stacks of them in the Northern Hemisphere. And notice they're all from that period up there, not down near the equator. And then less down here. You need a lot of money to start drilling the ocean floor and getting samples and trying to work it all out. The yellow is changes in dryness. The green is changes in wetness. Whenever there's climate change, some belts will move. We're not denying that. Victoria, as the polar high pressure system shrinks a little bit as the world warms, the low pressure systems that give you a lot of rain will retreat a bit. Victoria could become a little bit drier, and southwest Western Australia. So there's the medieval period. Go back 2,000 years, we're in the Roman period. Now look, it's warmer again. The vineyards in England are now near Hadrian's Wall. Very different kettle of fish. The German vineyards, they're at altitudes higher than the vineyards are today. Cave temperatures from South Africa show warmth. We can analyse stalagmites in caves and work out the air temperature in the caves and the water, etc. Now during the Roman warm period, we're worried about glaciers retreating and say how dreadful what's happening today. 218 BC, Hannibal crossed the Alps to invade Italy with 80 elephants and 50,000 men. No trouble. If you go back 3,500 years, we're in the Minoan period. Now, the civilization in the Mediterranean was centred on all these islands. Knossos and Crete. So these are famous places. And then there was a huge volcanic explosion on this little island, Santorini, and that just about wrecked Minoan civilization. The explosion did have some effect on Greece, but not as much. And so after that civilization was wrecked, Greece then had the impetus to recolonise the whole place, and it was Greek civilization that flourished. There are various professors looking at glacial retreat. This one's from Switzerland, but also Dr. Melanie Leroy in southwest France, the University of Savoy, trying to work out what the glacial retreat was in those periods. You can see the significance of the Minoan warm period and the Roman warm period from that diagrams of glacial retreat. So how unprecedented is the fact that glaciers are retreating today, and they haven't even retreated as much as they did in Roman times. So there's your Minoan warm period, and Roman and medieval. But when we go back 7,000 or 8,000 years, this is the warmest period since the last ice age. It's called the Holocene thermal maximum. There's no debate about it. Now, it's a very sustained warm period, about 3 degrees warmer than today, and if you're worried about the world's going to collapse, if temperatures don't go up more than 2 degrees, or go up more than 2 degrees, well, just relax. What's interesting in this period, there's also a few quick cold snaps, and we'll see a bit about that in a minute. But there were oak forests and mistletoe in Norway and Sweden. In Scotland, pine stumps, well above the present tree line. In Australia, the rainforests that are now up around Byron Bay, down near Maruya. Swamps, like the Wingecarribee. I was the first person in Australia to analyse the Wingecarribee swamp, back about 4,000 BC. A bit older maybe. It was a lot wetter, and climate was much warmer than today. Now those rainforests have migrated northwards. You can see there's a few jumpy bits in this period. There was a famous cold snap over 7,000 years ago. And we talk about rapid climate change. You've got to be joking. This snap happened within 30 years. It seemed to be mainly a European event, or a Northern Hemisphere event. My wife is here today, and Geraldine Starr's here. There is a Neolithic village near Petra in Jordan. And this is one of the oldest examples of the start of man making villages. They had goats, they had nearby grasses for grain, and they were able now, instead of being nomadic, to settle in one place. Within 30 years they had to go back to being nomads again because the climate had got so much colder. That cold snap, by the way, was short-lived. It only lasted a couple of hundred years, but it happened. So we're now much warmer than today. So is the world warming or cooling? Gosh, if you look at the last 8,000 years, we've actually cooled. Now, in that period from 9,000 to 12,000 years ago, we had these super floods. And these have got to be the most dramatic climate events in our near-term history. A lot of people think that when there was an ice age in Europe and North America, there was an ice sheet, maybe like thick snow. We're talking about ice sheets 2 to 4 k's high. We're talking about twice the amount of ice that's presently in Antarctica and Greenland. Now imagine as that ice sheet started to collapse, water forms 2,000 metres up on the top of that ice. Imagine if now some of that water starts to collapse and pour on the landscape. How dramatic is that? One of these famous floods, the Russians have mapped it in Siberia. It's on the corner of Mongolia, Kazakhstan, China and Russia. And there was an area there where one of these lakes was still dammed by ice, and then the ice dam broke. A wall of water 600 metres high spread over the landscape. 600 metres high is the estimate of the... This event only took a couple of days. It would have been over 1 million a day. The turbulence must have been hundreds of kilometres an hour of the water. Put these waveforms in gravel and solid rock. The waveforms are nearly 20 metres high, 200 metres apart. In Canada, they named the sort of lakes that formed on top of that ice sheet there, after Agassiz, a famous Frenchman who first proposed that Europe had suffered a number of ice ages. Agassiz actually started life as an expert in fossil fish, by the way. He got his ideas from another Swiss guy who was quiet, but he became the mouthpiece, and then he was the one who really promoted the idea of ice ages in Europe. This lake collapsed a number of times, sometimes pouring into the Hudson Bay, sometimes coming down over the American landscape. In Montana, one of the famous surges of this water, I call it the flood of Lake Missoula. It etched out this landscape in a day. Imagine what, if we were around at that time, what we would have thought about climate change. The guy who proposed this, Betts, in the 20s, he said it's got to be water at almost supersonic speeds. There's like tornadoes in the water, and when they hit the rock they drilled into granite, leaving circular holes in granite. How do you do that? You need water at incredible speeds to do that. And when he proposed it in the 20s, everyone thought he was mad. In the 60s, a small lake in Iceland collapsed, up there in the glacial fields in Iceland, and poured down the side of a mountain. And an American geologist just happened to be there at the time, and he saw all these boulders bouncing around. He said, hell, that's what Betts recommended in the 20s on a bigger scale. He must be right. Anyhow, when Betts was 95, they gave him the American Geological Medal. And he said, the trouble with you guys is you give me a medal now, but all my opponents are dead. So the world was dramatically coming out of that ice age, and if you look at it, sea level's rising and it's all over the place. But if we go back 18,000 years ago, as I said before, these ice sheets on Europe, and there's much more ice than presently on Greenland and Antarctica. So we go back another 100,000 years, we're coming out of an ice age before that one. So if you look here, if you go look at the ice cores, bang, 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 bang. If you go back a bit further, bang, 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 bang. Pretty well every 100,000 years. And then inside that, there's other wobbles. One of the main wobbles is, looks like every 41,000 years. So during all of those 100,000 year cycles, the ice advances, sea level drops 130, 140 metres, and each warm period only lasts 13 to 28,000 years. So sometimes in the future, our children in the future, children's children, maybe in another 15, they'll have to face, particularly in the northern hemisphere, an advance of ice that will destroy a lot of the icons of our present civilization. If we go back 2.5 million years, it's getting a bit interesting because the 100,000 year cycles have gone. Now we're getting these 41,000 year cycles. A 41,000 year cycle is tied with a 2.5 degree wobble, by the way, in the Earth. And we'll get into that in a minute. If we go back 5 million years, we're getting warmer again. We go back 10 million years, we're warmer again. And I'm sorry I'm not showing a lot of Antarctic photos, I'm only showing 2. But this particular valley in Antarctica, Wright Valley in Victoria Land, now there's been a geological fault, so the ice can't go down the valley, and the winds have blown the ice out of the valley. So we've got 3 valleys. One's got salt lakes like the Dead Sea. One's got 20 kilometres of sand dunes, as if you're in the Arabian Desert. And I was one of the geologists that worked in this area, and I was the one who dated this particular valley and shifted its age from 6 million years in the past to nearly 15 million. And that was one of the reasons I got the award for Scientist of the Year in American University 4 years ago. But look what's happening. This is underneath the glacier, like in Greenland, water from the ice cap is coming out of the glaciers. The pressure of the water is helped by having all this ice above it, and the force of this water is creating this labyrinth underneath the glacier. So now we've got meltwater in Antarctica. There's no meltwater in Antarctica today. There is in Greenland in the summer, in the mush days, for about 1.5 months. Now I might surprise you, but you might think that these little gorges are little, right? I took this photo from a twin-engine Iroquois helicopter. We took the doors off. I was given a belt, and it was chained with a chain to the helicopter floor, and I was standing on the edge of the helicopter, leaning out in clear air, taking this photo of 10,000 feet. We took these photos late in the afternoon because it's only then you get a bit of shadow. You're in 24-hour daylight, but you get a bit of relief. Going back to these little gorges, that is one of the gorges in the labyrinth. A few hundred metres high. The scale is unbelievable. That icefall in the background is 1,500 metres. We had to get one of our scientists fell for his death over here and rolled down here. We had to bring his body back. We're talking about sides in some of these valleys up to 2,500 metres. And there's no reference, there's no trees to say how high things are. It's just bizarre. You just look at it and say, oh, I just climbed up this bit of a side of the hill. And it's a different world too. Now, I could keep going on this, but surely, as members of the Academy of Lynxes, we can see there's a lot of cycles, there's a lot of things going on, and climate's not this simple business tied in with changing CO2. There's many cycles operating in different time spans in varying areas of space. We're going to look at some. Now, if you think this bloke looks like a nerd, he is. Professor Nir Shaviv from the Raka Institute of Physics in Jerusalem. He analysed meteorites, isotopes in meteorites, and came up with the statistical fact that at various times we had ice ages, and you can see it in the amount of isotopes in these meteorites. And then he said, wait a minute, every time we're a pilgrim in the solar system, and the solar system was wandering around the Milky Way, and he said every time we cross one of the arms of the Milky Way, we've got a series of ice ages. Now that's tying in with my isotope analysis of all these meteorites. He happened to be at a meeting, he didn't know about this guy, with Jan Weiser, a Canadian, and he was analysing, I talked before about these little fossils on the seafloor, and he was analysing them because you could tell from them using oxygenating 16 isotopes the temperature of the water at the time. And he did graphs of water temperature at the base of the ocean for the last 500 million years. They found that their two graphs coincided. They found that we had this oscillations every 143 million years, and then there was these minor oscillations. It seems that the solar system is walking along, it's bouncing up and down, but then when it crosses an arm of the Milky Way, we've got a series of ice ages. There are Danish experiments now to explain that. In other words, that when you go through one of these arms, there's a lot more cosmic radiation that's coming in at near the speed of light. The stuff from the sun is nowhere near that, the particles from the solar wind. And that can create certain isotopes which you can analyse. So what they've done at CERN, at a particle accelerator, they've started to muck around trying to hit various things. One of the things they found that, I'm sure our dog could smell a lot more gases coming from all the trees than we can. We go to some trees and we can smell what's coming out, but there are gases going up in the atmosphere. And some of these, when they put them in a particle, they found that once you charge them, you accelerated the possibility of clouds forming in a cloud chamber by 10 to 100 times. So what the Danes have been suggesting is that when this happens, you're getting a slight change in cloud formation around the Earth. More clouds mean shielding the Earth from radiation. helping to cause coldness. So we've got cosmic weather. Before I mentioned the 100,000 year cycles and the 41,000 year cycles from a wobble, and there's another cycle where the Earth is tilted, but then that tilt rotates every 26,000 odd years. So there's three different things going on. The first guy who worked out some of it, but not mathematically enough, was James Kroll. Now, every time we analyse some of these really bright people around, we just shake our heads and just say, how the hell did these guys do it? Kroll left school at 15, worked in a flour mill, worked on a farm. He eventually got a job as a janitor in the Andersonian Museum in Edinburgh. And he started to read books there and started to produce articles on how changes in the path of the Earth around the sun could affect climate. They eventually elected him to the British Academy of Science. You really wonder how many brilliant people are around that never went to university. Who could have done things and never were given the chance. Milutin Miligovic, he was a Serbian mathematician. He started to play with this. And in the First World War, he was captured on his honeymoon. But because he was a scientist, they put him under gentle house arrest. And during the First World War, he worked out the mathematics of the 100,000 year cycles, the 41,000 years, etc. But it wasn't recognised he was right until they started to do a lot of ice cores after the Second World War. Now, there are also other cycles, sunspot cycles, we can mention them in a minute. Jupiter and Saturn are so heavy, they cause the sun to wobble over 180,000 years, 180 year cycle, 179 year cycle. And the difference is 1 to 2 million kilometres in the solar distance from the Earth. There's also 1,500 year cycles, roughly, that we still aren't able to explain properly. With regard to sunspots, these are related to slightly colder areas on the sun. They form in these vortices, are magnetically linked in pairs, and they are also related to the sun's magnetic field. Now, our magnetic field hasn't flipped for 700,000 years. The Brenner's event, it happened then. So occasionally our magnetic field flips. The sun's magnetic field flips every 11 years. And the sun, parts of it are spinning at different rates. The core is spinning at a different rate to the whole section near the equator, and the bit at the poles at a different rate. So you can imagine, like brake pads, the sparks going off, the different magnetic fields that are being formed, and that magnetic field goes out way past all the planets in our system. And that magnetic field is a shroud protecting us from cosmic radiation. So if it's a little bit less, we get a bit more cosmic radiation, a little bit more cloud. I won't go through all these characters, but the development of sunspot theory was a lot of people. One of the interesting guys who recognised the 22-year pattern, like an 11-year cycle in one hemisphere, flipping to the southern, we suspect that a lot of his work came from his second wife, who was an Irish lady. And of course, in those days, women didn't get much credence for science, but behind the scenes, we think she was responsible. Hale was an American. He was making telescopes when he was 14 years old. But when we look at sunspot data and bioisotope data from the rocks, we can see not just that period in the 1600s when it was cold, but we can map cold periods going back a bit, and we can map warm periods going back a bit. You can see them all here lined up, and it's amazing what people are finding out about our past. I mentioned now this idea of an impending cold period. The last cycles, 21, 22, 23, 24, now we're in 24, sunspot numbers dropping. The Russians think there's a lag with the oceans giving out heat, but they are predicting a cold period that could affect the wheat fields in Belarus and the Ukraine by about 2040. There's an English physicist, Professor Zarkova, and she's also with her team saying the same. So what I say in my book is that the United Nations has to look at how we have to adapt to global warming. Of course it has to do that. But it also has to look at the possibility of global cooling. Because what could that do? I'm not talking about another ice age, but enough to shift around, say, the wheat belt in Canada or something. That's also fairly important for the human race. Now there's a lot of other climate cycles. You've heard some of them, like the El Nino cycle. The 60-year cycle in the North Pacific is a switch between the East and West. The North Atlantic oscillation is a North-South oscillation that affects rainfall in Britain and Iceland, etc. So we've got a maze of all these cycles. And with so many of them around, some seem to agree that there could be an accident. Some cycles could drive other cycles. There would be cycles we don't even know about. And who knows what time spans and area of space these unknown cycles may operate in. So whether we understand this cycle or not, going back to the early people who saw the sun coming up every day, but they thought the earth was flat, but they still had a cycle for the sun, those patterns exist, and those patterns are real. So if we put out our faith in models, I don't think being rather stupid, we've got to look at models, but surely we've got to look at all these patterns. I love this. Professor Wallace Brooker was the oceanographer of the 20th century. He was the one who worked out how all the oceans are connected to the big polar current around Antarctica. His equivalent in the 1800s was the famous German von Humboldt. When he received the Crayford Prize in Sweden a few years ago, he said, "My lifetime study of the climate system has humbled me. I'm convinced we've underestimated the complexity of this system." Now it is argued that carbon dioxide is responsible for the modern warm period, and the Industrial Revolution started to affect CO2 from around 1850 onwards. But it was only going up at about 0.3 of a part per million then. Now it's going up over 3 parts per million per year. And that is a graph of CO2 increase since then. But there are problems blaming CO2 for this modern climate change. The first problem was worked out by John Tyndall, an Irish physicist. He worked as a surveyor. As a young man left Ireland to teach at a school over in Wales. He was bored with another teacher, said, "Let's go to Germany and do some science over there." English science is a bit crappy. Studied science, PhD in Germany. Came back and was elected to the institute in London. Then he got interested in what effect the atmosphere could have in terms of absorbing heat and keeping the earth warm. The French had suggested the idea, but no one had proved it. His experiments showed, what I've been talking about all day, that water vapour is the king. Oxygen and nitrogen are not greenhouse gases, but methane, ozone and carbon dioxide are greenhouse gases. I won't go through, if I had a half an hour I'd explain his experiment. But what he did, he put gases in this brass tube. He couldn't put glass at the ends which trap heat, but he found that rock salt plates that you get from Germany allow heat to go through, so he used those, and then he would see what happened as whether heat got through that tube or whether it didn't, and analyse the differences between the gases. He gave a lecture about this, June 1859, with his close friend and supporter Prince Albert as chairman. And Prince Albert was Queen Victoria's husband. So water vapour is the king, responsible for at least 90% of the greenhouse effect on average. So Tyndall's been proved to be right. I showed you this before, how water vapour swamps carbon dioxide. And carbon dioxide is doing some damage in terms of warming, but it's a minor player. And tinkering with that, I'm afraid, is not going to do much good. I mentioned this before, that history also shows that CO2 can't stop an ice age happening. But we also got other problems. First of all, the modern warming started well before CO2 started to go up in 1850. It started in the late or mid-1700s. As a matter of fact, in Antarctica, one of the cores in the Brine Coast, the warmest rate of warming that happened was in the mid-1700s in Western Antarctica. This is a map of hundreds of glaciers retreating and the rate of retreat. Now, as CO2 is accelerating, surely the rate should have steepened, but it stayed pretty constant. So how is CO2 affecting the rate of glacier retreat? We've got another problem. This is from Professor Michael Aston at Monash here in Melbourne. But the same stuff has been done by Professor Jones from the University of East Anglia in England. The warming gradient between 1900 and 1945 is the same as 1975 roughly to 2000. Vastly different rates of CO2 change, yet the same warming gradient. And then we've got other periods here where things have gone sideways, but CO2 hasn't stopped. So the correlation is very messy. If you look here, again, there's a correlation here, but that's the only place really. And sadly, model land developed between 1975 and 2000 when CO2 seemed to be going up with temperature. I debated with Professor Harner at the University of New South Wales at the Legislative Assembly of the New South Wales Government 2 years ago when they opened it for a global parliamentarian day. And Hammer was saying, look, temperatures, CO2 is going up, temperature's going up. By the end of the day he came to me and said, you seem to know a bit about climate. But anyhow, look at these differences. Rising at 2 parts per million warming, rising at 3 parts per million pausing, 7 parts per million cooling, 15 parts per minute warming, 20 parts pausing again. The correlation between CO2 and temperatures not there. So what does Professor Agosopoulos say? He's now retired, well, a world expert on the ionosphere and the Van Allen radiation belts, etc. Professor from the University of Alaska. He said, what I see is warming, and I see oscillating warming. But he said, what's happened, everyone, when climate models on steroids, the models took off here, whereas we should have been doing that. And I think what he thinks he's seeing into the future is transposing something pretty real into the future, which does make sense. Now, what does James Lovelock see? I had an email recently with someone, surely you've read the work of James Lovelock and the Gaia hypothesis. Things are going to get worse and worse and worse. I sent him an email back and I said, look, I'm sorry, you're out of date. Lovelock's changed his mind. The problem is we don't know what the climate's doing. We thought we knew. That led to the alarmist books, mine included, because it looked clear-cut. But it hasn't. The warming that he predicted hasn't happened. The climate's doing its usual tricks. There's nothing happening yet. You're supposed to be halfway to a frying world by now. The world has not much warmed up since the millennium, 2000. So how has climate science been so blind? I think it was trapped by short-term Dominic, I think everyone liked that slide. I think it's been trapped by short-term trendology, where all the models were tuned between 75 and 2000, when they seem to be, temperature and CO2 seem to be linked. I think the models were tuned with too much a high sensitivity, and that doesn't work. And I also think using this faulty satellite data seemed to reinforce the idea that everything was getting worse and accelerating, whereas the NASA want to get rid of that satellite. It is not accurate. So what do we see as members of this academy, and what are we going to say? Is the world warming or cooling? Just how important is carbon dioxide levels in changing them? How unprecedented is the present climate? We have to be very careful about what we say, because what we say often depends on what sort of glasses you're actually wearing. So as members of the Academy, what can we learn from history? We have to describe what we see. I think we've been stranded in a maze. I think we've been confused as in a hall of mirrors. Thank you very much.